Okay, so as we discussed in the last session also, which was taken by Abhinav, about the basics of Python. So we were trying to guide you for about one language which was needed if you were starting to learn machine learning. So we will today learn about the roadmap of machine learning and how you can proceed with it and why you should proceed with it, and if you're proceeding with machine learning, what you should learn and where you should learn about the topics. So let's get on with it. So first we'll because it will be needed in most of the algorithms of what is happening if you implement an algorithm and what is the mathematics of it. Uh, let's get on with it. So first we'll okay, hello. Hello, hello. Let's check the voice again first. If it will be clear, then I will be proceeding again. Just a second. Okay, hello. Hello, hello. Let's check. Okay, so I think it's now clear. So what I was saying is the last session which was taken by Abhinav was about the basics which was you needed to proceed with machine learning, and today I will talk about how to learn machine learning and from where to learn machine learning and why you should learn machine learning, and if you are learning machine learning, what are the resources you will be needing and from where you can get it. Okay, so the prerequisites are either one basic language you should know, either Python or R. You can know both of them, you can work on both of them, but one will be needed only, and the basic mathematics. So I was telling you about mathematics that if it's necessary that you know maths, and well, it's not necessary actually. If you don't want to know about the mathematics behind the algorithm, it's fine. You can still work on machine learning with that, but that won't be very much interesting as you won't know what is going on behind the algorithm. You will be just writing the code, and that's all. If you will know what is the maths that's going on behind the algorithms, then it will be a little bit more interesting. So I would say uh, mathematics will be a little interesting part in the machine learning if you will know about it. So yeah, these two things should you should be aware of if you are trying to learn machine learning. Okay. So these are the things which was taken in the session, last session by Abhinav. I think he covered all of these basics of Python. So I won't be saying anything about them. So yeah, so let's get on with what is machine learning. Okay, so the basic definition of machine learning is that it gives the computer the ability to learn without being explicitly programmed. So what does it mean actually? Okay, so without being explicitly programmed means that you don't need to write the code for each and every test case you are saying. Like if you're training a robot, you have made a robot dog. Okay, you don't need to program it to walk, you don't need to program it to run, you don't need to program it to handshake. It will learn it by itself, by watching the other dog, by seeing how, by collecting the data, by collecting data of what happening around it. Okay, so you don't need to program everything or code it everything what you need to do. You just need to put down the sample and it will automatically collects all data and will automatically output it in its own form. It won't be perfect, but it will be somewhere next to perfect. Okay, to get the perfect result, we use different kind of regularization and improvisation uh, that we will talk about on later. It is also called loss function and some other things. There are many things about it. So, and the other definition, which is a little more static, is a computer program is said to learn from experience E with respect to some task T and some performance measures P. If its performance of T, which is a task, performance of T as measured by P, P measures your performance, okay, improves with experience E. So you see, here we are improving with the experience. So here E becomes the loss function. What is E doing? E is minimizing the error that we are making while giving the output. And how E is minimizing the error? By getting more experience, by getting more data. Understand it? So the next definition was given by Tom Mitchell in 1998, by the end of 20th century, approximately 98. Okay, so we can divide the machine learning problems in six different parts. Okay, so before getting into the problems, let's get into what are the algorithms. Or okay, discuss the problem first. So first, you should know about the data. You should see what is in the data, what are the categories that are defined in the data, whether outputs are given or not. If outputs are given, then it will come in supervised learning, otherwise it will come in unsupervised learning. Okay, so and the main part, tasks. Okay, the task is the main part because um, after seeing the data you need to know what are the tasks that you can get after from that data, or what are the tasks that you can provide to others from that data. From from one data set you can provide many tasks, like if you are given a data set of like basketball players of 10 years. Okay, then what are the tasks that you can provide, that how much a player is earning per games or per match or per goals he is conceding, or what is the accuracy or what is the accuracy of per match, or what is the accuracy per salary. Understand? Like how much money is he getting for the each goals, and is this accuracy good comparing to other players. Understand? So these are the tasks that you can get from just one data set. Got it? So task is one of the most important thing over here. You need to understand what are the tasks that you can get and what are the tasks that you can provide also. And let's get on with model. Model is nothing more but the algorithm itself only, but uh, algorithm in the form of um, libraries kind of, you know, like we say superverb. reinforcement learning, and classification and regression. Okay, so these are models. Like, you will work on it, and then you will just see the output if it matches with the data set or not. If it does, it's good. If it's not, then you will minimize the error by using loss function. Yeah. By using loss function has many things. So we will just be discussing, I think, sigmoid and ReLU. Okay, ReLU is nothing but a rectified linear unit. So yeah, sigmoid and ReLU is, they both are used for classification, and that that will be enough for basics, I think. And algorithm, there are many algorithms which we will talk when we'll move closer to the problems. Okay, evaluation is when the whole thing is completed, when you have completed the whole program, when you have completed the whole training the data set and everything, then you evaluate it to original data set, whether the answer you are predicting with your algorithm and loss function that you have used is how much closer it comes to the real answer or real data set. Understand? That is evaluation. It will come in percentage or in standard deviation method. So if it's 90% close, if it's 95% close, if it's 80% close, these are good values. If it's less than 80, then you can use maybe more. Maybe you can try to minimize the error more. It depends upon you. How much you can minimize the error, it's great. Understand? So yeah. So the first algorithm is supervised learning. Okay, so supervised learning, when you will know when you are given, when you need to know supervised learning algorithm or not, because in supervised learning data set, the output is given, the right answer, the right output is given to you, and you just need the your model or your algorithm just need to predict predict the relation between the inputs and the outputs. Okay, and when it will predict the relation between the input and the output, it will automatically, when it comes to the test set, it will do the same with the test set. When the input will be given, it will use the same relation with the test set and just predict the output. Okay, sometimes it will be wrong, but most of the time it will be correct also. Okay, so, and as per of the evaluation, when it will predict the value, you can then compare it with the real values, as the real values will be given in the supervised learning. Then evaluation you will get it. Okay. In supervised learning, there are two things: regression and classification. Okay. Regression. It is a there are two type of regression that we'll mainly discuss: linear or polynomial regression. There is multiple linear regression also, but not necessary. It will come in linear regression only. Sorry. So regression gives us the real valued output. Like if we take an example, like you are going to buy a house. Okay, so there are many factors which you take into your mind, like what is the size of the house, what are the square feet that you need, how many rooms does he have, uh, what is the location, what what is the price. Okay, so these are the factors that you keep in mind, and then along with that, a price is the broker gives you the price that this is the house of the price that is coming. Okay, so then you check with all the data set you have, you check that that the price given by the broker is correct or not. Like, should it be the price that I should be buying house, or you can check over there. Like data set will be given like three rooms. The location is perfect for you. That will be one in Boolean. and then the size of the house will be given, and it will map it to the real valued output, that is the price. Then the relation will come like how much greater the house price is. And then for another square feet house that you want, like 1,000 square feet house, you checked for 300 square feet house, and if you want a price of 1,000 square feet house, it will tell you the price of 1,000 square feet house by itself only. Okay, and it may be correct, but it will be next to correct only. Okay, as you know, error is always there. Error is it's very rare when you see there is zero error, because it's actually impossible to get the zero error. There will be some kind of error which will be possible in some kind of data set. If it's not present in your test set, then it will be present in some other test sets. Okay, there are many data set available. So yeah, in classification, the main difference between regression and classification is regression gives the real valued output, that is in um, in any numeric value and decimal points, and classification gives the discrete output, either 1 0 2. Okay, multiple classification gives 2 3 also. So yeah, classification gives the discrete valued output, whether it's right or wrong. Okay, if it's right, then what kind of right it is, that comes in classification. Okay, if you want an example, the most basic example of classification is when you are detecting benign or malignant cancer. You must have known that the most basic project or most basic thing what you do with classification is detecting a malignant or malignant cancer. So what does it do actually? The thing when machine learning enters into the field of medicine, uh, the first thing it did is it predicted when the patient has had cancer, whether that cancer will go into the benign category or the malignant category, and how it predicted the mm, the symptoms were given by the doctors itself. If these are the symptoms, then it goes to the malignant cancer, and if these are the symptoms, then it goes to the benign cancer. Okay, like if four of the symptoms are true or three of the symptoms are true, whether you will give it to the benign cancer or malignant cancer, this depends on your algorithm, what you are implementing. Okay, and the data set too. So when you will implement it, you will know it. But these two are the basics of supervised learning. Okay, let's get into unsupervised learning. Okay, unsupervised learning, as I said in the supervised one, that output is given. In the unsupervised learning, output is not given. Okay, you have to know it by yourself. What can you predict from the previously detected undetected patterns? You will detect the patterns, you will detect the relationship between the inputs, and what you can predict with it. You have your algorithm will know it by itself. Okay, and there will be no or a minimum of human supervision. As I said, with a minimum of human supervision, there will be no or minimum of human supervision. Okay, so as an example, we can take associative rule learning, which is a very good thing. Associative rule learning gives is the base of recommendation system. Okay, the recommendation system which you see in Amazon or Google and any other website. All the website now has recommendation system. They when you open something, like you have opened like you are searching for a mobile phone, and you opened like, just take any phone, Samsung M10s, like Samsung M10s. Then in the bottom when you go down, it also shows that people also viewed for, that is recommendation system. People also viewed for what, it will show you people who have opened Samsung M10s have also viewed these things, and it has collected those data, and which are the things that are most viewed by people. It shows you. and if you click on that data, then it will collect that you have clicked on this one. So it will so the next person who comes, that will be the first thing he will be shown in the bottom. If he goes, people have also viewed for these things. Okay, so there is no output. It just collects the pattern and gives the output by itself. Okay, and there are three kind of model that comes into this: clustering, associative rule learning, and dimensionality reduction. Okay, about them we will know in more details in the next or the upcoming sessions, I would say, because roadmap is very big. I'm trying to cover up in the most short form we can. There are some more topics, of course. There will be some more topics. I have forgot to mention one more topic, which will be NLP. NLP is one of the most important topic in the machine learning. It is natural language processing or neuro linguistic processing, whatever you want to call it. So yeah, ch- the resources for that I will provide over there. I'll provide over here means I'll provide over here what are the resources and from where will you get it. And yeah, NLP I have missed. I will put it down somewhere. Yes, sorry. I will write it down NLP. Okay. So in symbol learning, neural networking, and deep learning. Deep learning, deep learning, like the basics of deep learning, you need to know in machine learning, like ANN and the basics of CNN. Not the whole CNN, but the basics of CNN. What is CNN and how does it work? What does it do? Understand? That comes in deep learning, but only the basics you need to know during machine learning. You know, reinforcement learning, that's also in machine learning, but this will not be covering in these sessions because this is not the basic. Like this comes in, you can say, intermediate level or a little higher level. For the basic projects, these five models are enough: regression, classification, clustering, associative rule learning, dimensionality reduction. Okay, mostly you will be using regression and classification, so we will focus more on this because most of the time you will be using regression and classification only as supervised learning is the most important thing. And then we'll also move on to clustering. Clustering is also one of the most important in the unsupervised learning. So yeah, clustering is also important. So regression, classification, clustering. These three are the most important. We'll focus most on these areas, and then we will also move on to associative rule and dimensionality reduction. But we will give a little time on that. Okay. So yeah, about the resources. There are many resources available. Okay. If you are interested to know the maths, which I would suggest you should at least just take a look what are the maths behind the algorithm and how is it working and why machine learning is so popular because of it. You should know why machine learning is so popular that nowadays everyone wants to learn it. Understand? So mathematics, I would suggest you to go and check the course once of Andrew NG, which is available on Coursera. Okay, it's free. You can just go over there and take a look. You won't get a certificate for free. For certificate, you will have to pay some price. But for the courses, for the course materials and all, you will get it for free. So I would highly recommend you to go over there and just take the course once, learn it. It will only take up to 3 weeks or maximum 4 weeks. Maximum 4 weeks it will take of yours to complete it. I would highly suggest you to go and learn from there. The maths, Andrew Ng is like the best present in this era on in the machine learning field. He has created many things from machine learning and deep learning. So yeah, you can call him like the godfather of machine learning and deep learning in this era. Other sites that you can look for are Made with ML. Stanford University is the CSG 20, which I've written, is also of Mother Andrew Ng. He has mentioned it's a book of his. He has mentioned all the mathematics and the things which will be teaching in its course in this book also. Okay, Udemy, you can prefer Udemy also for hands-on. Okay, after you will be done with Andrew Ng course on Coursera, you will have a little bit knowledge of hands-on, but I would suggest you to know a little bit more of hands-on of classification and regression from Udemy, which I'll be also saying, okay, which I'll be also teaching about how does it work or not, okay, and what are the libraries that are needed if you will be doing hands-on of regression, classification, and other algorithms and all, okay. So yeah, these are the courses, and if you want to know more about the courses, I will put down the links of it after the stream ends. Okay, I have already mentioned that. Okay, platforms from where you will be practicing all of these is Google Collaboratory, Jupyter Notebook, MATLAB. MATLAB I won't suggest you because it's outdated now. I've already written outdated. So MATLAB is outdated because no one uses it, and it asks you to use I say um, Python 3.6 and Python 2.7. Also 2.7 will be needed for some of the algorithms. Um, these both can be used in Google Colab and Jupyter Notebook, and do provide amazing features. Okay. In this course, in this session, whole session, we will be using Google Collaboratory. Jupyter Notebook we won't be using because Google Collaboratory provides all the features which is needed, and it also links it up to your drive, so there's no need to store into local drive system and all. So yeah, Google Collaboratory will be the best for using it right now. So these two platforms I would suggest: Google Collaboratory or Jupyter Notebook. If you don't have regular internet, then you can go for Jupyter Notebook. Jupyter Notebook is offline, but still you will be needing some of the internet to like turn it on. Like when you install Anaconda, I will show you how to install Anaconda. I'll put down the link of Anaconda, and you can install it from there. And then Google Collaboratory is online. You just need to search Google Colab. It will open up. You need to sign in to your drive and connect it, and it's done. You can just start working on it now. Okay, so it's done. Thank you. And if you want to see what a machine learning project look like, then I can show you one. Okay, just 1 second it will take. Okay, so about the project I was saying, as it is uploaded in GitHub, so I cannot open in Google Collaboratory right now. If you want to see it in Google Collaboratory, I have another thing opened over here, which is the visualization of vectors. Okay, so I will show in both of them. This is how it will look in Jupyter Notebook. Okay, so it's a project on sentimental analysis using NLP. Okay, or NLTK library. NLP is neuro linguistic processing. I told you already. So this is how we will retrieve the data set. Okay, all the coding is done over here. This part is the coding part. We have imported libraries, we have removed the stop words and all. Okay, uh, for now it will be, I don't think you will understand all of it right now, but just to look how it will look, how it will work, you know, the data set I will show you right now. Like, look, we have removed in this part, in this coding part, we have removed the stop words. Like when we write a review of a restaurant, we always write wow, then we put on some dots, three dots or four dots. It was a lovely place, and this it was, the food was not good, or the food was great. You know, these the was, these are the stop words. These are the things which on which our our uh, output shouldn't depend on. Okay, so we remove those things. Okay, using NLTK library, we remove those things, and this is how you will remove it. Okay, and this will be how it will look like if you remove all the stop words. Okay, wow, love, place, only this, trust, not good. Okay, this is how it will look. Okay, and then after that we will create a bag of words. We will put all of these words in a, like, in a bag of words. Okay, and then we will predict the output. The most important thing, we'll predict the output by training our data set on the training set. Like if you have thousand data, you will use 2000 for training set, and the rest of 8000 for test set. Okay, you will train your model in the training data set, using this. How I am importing and how what I am using, I will tell you in the later session when we will be doing hands-on. Okay, it's just a project representation. Okay, and here over here we are training the model and all. Then when I predicted the results, it's this. Okay, you can see 0 means the rating was bad, it was not good. Negative, negative response, negative response, you know. All we can see is 1 1. On the left side it's the correct output, on the right side the output I have derived from the relation. Okay, so you can see some of the output might be wrong, like over here it's wrong in both of the cases, you know. So after predicting or everything, after predicting the output also, we have evaluated whether how much I have predicted right and how much I have predicted wrong. So it's 0.8, which means 80 percentage. Okay, 80% of the thing I have predicted right, and 20% I have predicted wrong. It will be, it can be, you know, it can be more also, the accuracy, by taking by taking up a greater loss function model, or better error reducing model. So yeah, this is how you will make a machine learning project. It was a very short one, but most of the machine learning model will be bigger than that, or you will require more coding also. So, and the other thing which I will be showing on you on Google Collaboratory is this. Okay, I have already coded it, so it's a visual representation of how you will do things. Okay, like we are plotting vectors. Okay, we have plotted vectors of different magnitude, different different directions. As you know, vectors have directions of its own. So these are the magnitude and directions of the vectors. Okay, we have put them in an array and then plotted them. So this is how it will look like, and we have also put the dot product of it. Like when you will do a dot product of it, it will go 90-degree up or 90-degree down. Okay, like perpendicular to its the adjacent one. So this is how Google Collaboratory will look like, and this is how you will work on it. Like you will import it from over here. You can just write over here only. Okay, just you can just write anything, and for running you can click on this or shift plus enter. Anything will work. So for shift plus enter, you will go below one cell and then you can work on that. And if you want to stay on that cell and just run it to see whether what you have written is right or not, then press Control plus enter and it will run. Okay, it is allocating over here and connecting. When it will be connected, it will run by itself. Okay, so as I said, it will you will need an internet connection to run this. Initializing, connected. Okay, great. Okay, you see it has already run. Okay, and when I click on this, run once again, no error. Of course, there will be no error. We are just importing the libraries. Okay, so this is what I have done for visual representation of vector. Okay, just to show you how Google Collaborative works and all. It is linked with your Google Drive. Okay, you can see my email is opened up over here. So yeah, these are the two pages I want to show you. um, this is not a project, this is just a practice of visual representation. This is not a project. This one was the project, and yeah, done. So thank you for staying throughout the live. Yeah, so now I will be ending the stream. Thank you very much. Okay, sorry, I was muted the whole time. Okay. I showed you the whole project and I was muted. Okay, it's fine. I will show you again, no problem. So over here, it's what you're seeing is the Jupyter notebook. Okay, it's a Jupyter notebook, and the Google Collaboratory one I will show you once again over here. I have showed, but I was muted, so it's fine. So what I've done in this project, I've used NLP, neural language processing. Okay, and removed all the stop words from a review, like the review you see in Google or in anywhere else, in Zomato also. You see there are some negative reviews and there are some positive reviews. How you differentiate between them is this. Okay, you just I removed the stop words and I predicted whether the review what the user is saying is positive or negative. So the first result you are saying is the actual data set, because it's the supervised learning, so it's the actual data set. So it was a negative review and we have also predicted the negative review. Okay, so it was a correct one. So great. So and we have trained the model over here and split the data set. Yeah, splitting the data set is one of the most important part, because you split the data set into two parts: training set and test set. Training set, because you train your model on training set and test your model on test set. Okay, um, so when you train your model, it takes up a relation that okay, these are the things which I need to consider while making the outputs, while predicting an output. Okay, so that's how it works on test set also. Okay, uh, so over here what we are predicting is on test set. Okay, predicting the result on test set I've already written over here. Okay, then after that we have evaluated our results, like how much is it correct or not. 80% of our results were correct. So yeah, that was pretty decent. We can use another algorithm or another loss function algorithm which will work better, but for now it's this. And this is one of the project, and it is shown in Jupyter Notebook, and it is available in my GitHub only. So I have opened up in Google Collaboratory. For Google Collaboratory experience, I will show you up in this one. Okay, this is not a project. This is just a visual representation of a vector. Vector we have all studied in class 12, like dot product, and after creating the dot product, how it will become, like this is the dot product of these two vectors. Okay, and like if you plot four vectors in one graph, this is how it will look like. And there are many visual representation mode, and this is how Google Collaborative looks like. Okay, so you will work on this only most of the time. You just need to search Google Colab and then click on the first link it to your drive, and this is it, or this it will open up. Okay, so yeah, that's it for today. Thank you for staying. Thank you.